Alright, in this video I'm going to show you a few things to get you familiar with the so-called logic chips. Alright, so logic chips are chips that act on digital signals. Okay, so digital signal means it's only got two settings. There's either a high setting or a low setting. And actually, usually, conventionally, these are capitalized. So high setting and low setting. Okay, so electrically, we're talking about something like positive 5 volts is a high signal, and the low voltage is almost always a 0 voltage. So high could be 5 volts, it could be 9 volts, whatever, but it only has two settings. Right? In the case of binary, which if you are doing a project that involves some binary understanding, you might want to watch my video on using binary code in digital signals, but just for reference, in digital language, we have a binary 1 is high and low is 0. So binary numbers are made up of 1s and 0s. So in computer talk, we usually refer to the high signal as a 1 and the low signal as 0. All right, so let's take a look at this first chip. This first example is called the NOT gate. All right, another name for this is the inverter. All right, for a simple reason. It has an input, A, and again, you only have two choices. That A can be either high or it can be low. All right, so it takes, the NOT gate takes an input and inverts it. So in this case, if I input a high signal, the output is going to be low. And vice versa, if I input a low signal, 0 volts, then the output is going to be high, or 5 volts, whatever voltage we're using. Okay, so that's the inverter. It's one of the simplest ones. It's only has one input. All right, so input A can either be high or low. Also, this right here, this is called a truth table. All right, it comes from, the term is used in logic, in philosophy, in mathematics. The term truth table refers to true and false. So another way, if we go back to our digital example, so a high signal can be high voltage, positive 9 volts. In binary, it can be 1. In truth table or logic terms, a high signal would be called true, and a low signal would be called false. So that's just another way to write these things. Okay, so let's move on and take a look at another one here. So here's another gate. We have an AND gate. All right, so the AND gate, now we have two inputs. We have input A and we have input B. All right, so from here on out, I'm going to do high. I'm going to notate that with just an H, and the low, I'll just notate it with an L. So we've got 4 combinations of possibilities. So the first one, we could have both A and B are inputting a low signal. All right, or sorry, let's do high signal. Both A and B are inputting a high signal. An AND chip is looking for both inputs to be high. If that condition is met, then the output will also be high. If that condition is not met, where both A and B are high, then the output will be low. So for example, if only A is high and B is low, then the output will be low. Or if A is low and B is high, then the output will be low again. Now here's one trickier one. Let's say A is low and B is low. Now we might think that because A is low and B is low, then the output should be low. That's actually not how an AND gate works. An AND logic gate only responds to high signals. In this case, what we would call that is we would say an AND gate is an active high gate. So it will only respond high in this case. So a low signal and a low signal will result in still a low signal. So we're looking for